Hello, and welcome to the Aquarium Online Academy. My name is Morgan. I work in the education department here at the Aquarium of the Pacific in Long Beach, California. In the studio, we have my friend Soraya. She's going to be controlling the media today. So today, we're going to be talking a little bit about tide pools, tide pool habitats, some of the living components, some of the non-living components. We're just going to be looking at pictures of tide pools and studying the animals up close. So, here we are in beautiful Tidepool Environment, a local one, local to Southern California. If you are watching this live and you have any questions or comments, please feel free to text those in to us. Here's our live number right here. So text us live questions to 562-286-1838. If you're watching after the fact, you can always email us questions later on at live@lbaop.org. So yeah, we love it when questions come in. So here we are. Let's put our explorer brains on. We are going to be diving into the tide pool environment. And so what are some observations that you can make about this environment, this specific habitat? I'll move off the screen for a little bit. So, something I see here is that there are crashing waves on these rocks right here. So one thing that I automatically know is that, okay, tide pools, they are going to be found along rocky seashores. So places where there are a lot of rocks, there's little crevices, little depression areas. So these areas are going to trap some of the water that's coming in with the tides. So when I say tides, I'll explain that a little bit later, but just think about the waves right now. Sometimes the waves roll in and sometimes they roll out. So we're talking about the water that's left behind when the waves are rolling out. And you can see there's actually a big difference here in this video clip between this area here, where the waves are rolling in and there's a lot of action, a lot of new water being added to the tide pools, as opposed to some of these areas back here, right? They're not really getting as much water exchanged. And now you can kind of see here that there are different zones to our intertidal zone with our tide pool habitats. So we're going to learn about some of the animals that live in these zones. We'll make some predictions about some animals and maybe where they live. But I want to explain to you tides. So what does that mean? What do you think it means, tides? So maybe you've heard about high tides, you've heard about low tides, and maybe you've actually gone to the beach and experienced yourself. So maybe you've gone to the beach high tide and you've noticed, wow, there's not a lot of beach here. There's a lot more water than there is beach. Or maybe you've gone down to the beach at low tide and you've noticed, wow, there's a lot more beach here and the water level is pretty low. We're going to dive into the reason for that. So just a very simple explanation. Come on here over to, all right, our document camera. So we'll give it a simple explanation again. Let's just draw our Earth here. So here's our planet. This is Earth. We'll label it Earth. And on Earth we have ocean. So let's represent the ocean as a circle of water around the Earth. Okay, so ocean. Let's represent our moon as our small little moon out here. Moon. Okay, so when we're talking about tides, we are focused on the gravitational pull between the moon and the Earth. So the word here is gravity. So gravity is the amount of pull on certain objects. And so a couple of the variables that come into play with gravity are the size of the object and then also the distance of the object. So we are focusing on the moon in relation to Earth because the moon is so close to Earth. Of course, the sun also plays a small role since it is such a large, massive object. But for today, we're just going to have a simple explanation focused on the moon. So, we are talking about the gravitational pull from the moon. So, we're going to focus on the gravity that's pulling on the ocean first. Okay, so here we have this orange line. That's going to represent the gravity pulling the ocean. Now, this is not how our ocean looks when there is gravity involved. So let's just draw. Here we'll add in a little change. So we'll change here. How our ocean looks with the gravity pulled by the moon. So we're going to have something called a tidal bulge on this side here. So right here, this ocean is actually being pulled closer to the moon by gravity. So that's going to create a tidal bulge. It's going to create a high tide here. And now something else happens too. Not only is there gravitational pull on the ocean, but there's also gravitational pull on the Earth, so the land mass. So we also have this other arrow here. That's going to represent the gravitational pull on the Earth. So we actually have to shift the Earth over as well. So we're going to go ahead and redraw the Earth. So, and I'm also going to redraw our tide here. Not a perfect circle, but okay, let me redraw the effect that this gravitational pull has on the ocean. So it's a little bit more clear. Okay, so now we have this bulge over here. And then we have another bulge over here. And of course, this part here, this part of the ocean is also getting a little bit of effect of gravity. But since it's further away, the effect is not as strong. So here you have it. You can see that here, this part, there's a lot of water in this part as compared to this part right here. And also this part right here. And then over here, we also have a lot of water. So this is going to represent our tides. So say that you're a person on the Earth. What you do every day is our Earth is actually rotating. So you're going to be rotating around the Earth, right? One revolution every single day. And so then your experience in the spot where you are is you're going to experience one low tide, one high tide, 2 low tides, 2 high tides. So this is going to give you the 4 tides. So roughly every 6 hours, you're going to have a change. Okay, so high tides and low tides are caused by the gravitational pull from the moon. So that is our basic concept of tides. Now, let's go ahead and check back in with our tide pools and look at some of the animals that are living in this habitat. Ooh, so this is actually a really fun exhibit here at the Aquarium of the Pacific. It's called Coastal Corner. And what I like to look at here are all the different animals in this tide pool environment. And one thing that I noticed is that they are all submerged in water right now. So this would kind of be like high tide. So this is how the animals look when it's high tide. Now, what animals can you spy in here? What do you see? I see some sea stars, right? Right here. It's a beautiful sea star. Some anemones here and here. And then right here. More sea stars. We have some urchins over here. So right now, all of these animals are probably feeling really good. They have a nice flow of water, which is going to bring to them some fresh oxygen. It's going to have maybe some prey for them to eat. It's going to be nice and fresh. It's going to be cool. It's not going to be too hot. They're not going to be dried out like things like the sun. Predators are going to not have as easy of access to get them. So they're pretty happy when it is high tide, when they're submerged. But as you know, there are periods of the day where they're going to experience a low tide. And so maybe we can pull up a picture of what some of these animals look like at low tide. Oh yeah, this is great. So this is a picture of when the tide has pulled pulled out. We can see here some sea stars. And now sea stars, they actually have an adaptation that allows them to move. They have, we'll get into it more later, but they have some tube feet on the bottoms of their bodies. Yes, this is great. Okay, yeah. So these tube feet right here, these help them move. They have hundreds of these on the undersides of their bodies, and they can actually sense light. So they know which way is light, which way is dark. Yes, here they are. This is a sea star moving right now. So sea stars have the ability to move. But one thing that you should keep in mind, and I'm sure that they do, even though they don't have brains, is that every time they need to move, they have to use this process that requires water. So, ooh, here's a great picture of the sea star moving. It's almost like it's just gliding along the bottom, like levitating. But those are the tube feet moving it along. So as they're moving, this process does use water. So every time that they're moving in a tide pool, they're actually losing water, which is so valuable because when the tide goes out, there sometimes is not any fresh water for many hours. Yeah. So these sea stars have decided, okay, I'm going to a dark, cool, shady place where the sun's not going to be too strong, where hopefully I'm out of the view of predators and I can survive here for the next however many hours until the tide comes back again. So those are those sea stars. That's their adaptations that works pretty well for them. But it is definitely a dangerous period of time. Now, these anemones here, they don't even look like anemones really anymore because those anemones have those beautiful swaying tentacles. Now, those tentacles are really important to the anemones because they actually help them sting and stun and capture their prey. So if an unsuspecting fish were to swim by, it would get stung by those tentacles and then brought into the mouth. Now the mouth is that little circle in the middle of their circular body. Yes. So here's a great picture of the tentacles of the anemone, right? All around the outside. So its body is a circle. We have tentacles around the outside of the circle. And then we have its mouth. Ooh, yes, its mouth in the center. So this is just a great adaptation for using those stinging cells that they have. So they're bring that food right on in. But when it is low tide, when they are at risk of drying out and they're not going to be catching any prey, they're here on the rock, they're going to bring those tentacles inside. Okay, they don't want them to get damaged. They won't be needing them right now, so they bring them inside. They kind of curl up. And something that I just learned today that they do, Sarai actually told me this, is that they put shells. So they will take their tentacles when the tide is starting to recede, and they're going to actually put shells on their bodies to protect. So this is going to protect from extra sunlight. This is going to protect from drying out. So those shells are going to protect, and I think they also do something that camouflages them. Because if you look here at this picture, you can see there's a bunch of barnacles on these rocks. So those are those little white, crusty looking things. They don't even look like animals. They kind of look like rocks, but they actually are animals. And so these anemones are camouflaging using some pieces of shells. Maybe to look like a barnacle. Who knows? But yeah, let's look. Yeah, let's look at some barnacles. So I have, ooh, yes, here's a great picture. So these barnacles, they're actually able to live higher up in the intertidal zone, in the Tidepool habitat, because of their body shape and their adaptations. They have these little volcano-shaped, almost like shells that are going to be very, very important for them. So they're actually going to be able to seal in water. They have this little door on the inside of their volcano shell that can open and close. Now, this door is going to open when they're underwater, and they're going to actually start feeding by sticking out their little feathery feeding part. But when they are exposed to the elements, when they're outside of the water, they're going to close that door. They're going to seal in the water. That's going to help them breathe, and that's going to help them stay cooler as they are exposed. So again, these animals are found higher in the intertidal zone because of these special adaptations that they have. So you can see here, right? So they would be found around here, and they're often found on rocks. So they're actually really, really hard to get off too, because they're almost like cemented onto those rocks. They are not going to move. Once they are out of their larval phase, they are stuck onto the rocks like cement. And we actually have an artifact here, a biofact of a barnacle. You can just get a little bit closer of a view. So let's look at this up close. So inside of these holes here, that's where the door would be. So they have this little door that opens and closes. And then you can see here, they have this whole space right here to hold on to water. So they are filter feeders, so they're going to hold on to some prey. They're actually going to get oxygen from that water as well. So you can see they also tend to live in little clumps here. They can live solitarily or with other barnacles like this, and they just cling onto the rock. So those are our barnacles. Yeah. Those are our barnacles. So, and sometimes barnacles are found with mussels. And now these sea mussels, they have the adaptation of having two shells. So similar to barnacles, they can open up their shells a little bit and get that water, that great circulation of water that's going to help them survive when the ocean is actually covering them, right? So at periods of high tide. But then during periods of low tide, they're going to go ahead and close their shells, trap some water in there, and stick it out for the next high tide. So you can see that they are living among some barnacles. So these are gooseneck barnacles here, and then we have other barnacles in the mix. So they all have a similar adaptation to withstand some of the dry times. So yeah, some of the, here we are, back in coastal corner here. So we can actually see urchins here. So there are urchins that live in tidepool habitats as well. And these urchins are going to have similar tube feet to sea stars. So they use these to feel around, to look for food. And these urchins are going to be much more stationary than our sea stars here. Here's a great picture of an urchin right here on a piece of kelp. So urchins are pretty famous for eating kelp. They like to eat, when they're not in a tidepool habitat, they like to eat the holdfast of the kelp, but they will also eat the blades here of the kelp. And so sometimes there are kelp blades that end up in tidepool habitats that they will eat. They do like algae. Yes, so here's a great picture of, or a video of a tidepool habitat. Right, this is at the very beginning of the habitat where there's a lot of wave action. Right, we have our anemones living here. So the anemones are going to want to live in a place where there's more water most of the time, so that they're not drying out. We even have fish here. We've got some kelp here. So let's look at some other animals that live in tide pools. Let's look at a sea slug. Do we have any pictures of a sea slug, and think about maybe where a sea slug might live in a tide pool habitat. So, so we have a sea cucumber here. Where do you think that they would live? Do you think that they would live in the higher part with the barnacles, with more exposure to sunlight, heat, less water? Or do you think that they would live closer to the ocean, maybe where the anemones are going to be living? Go ahead and text us in your answers, your predictions. Ooh, yeah, we have a sea snail right here. This is a chestnut cowrie. And these guys actually have a shell on their back. So any animal that's going to have a shell is automatically going to have protection. So these chestnut cowries, these sea snails, carry their shells around with them, and they're going to be able to trap water in their shells and actually protect themselves from drying out, from extra heat with that shell, because they can just bring their bodies right into their shell. So these animals, ooh, here we have a crab. So these crabs, they're extremely mobile, right? They're more mobile. They can move around a lot more than any of the animals that we've seen so far. Now, this is a really good adaptation because these crabs can actually physically move from tide pool to tide pool. So if they're in one tide pool and that tide pool is losing a lot of oxygen, if it's the water's getting really hot, or maybe there's even like trash or something in that tide pool, they can actually move side to side to another tide pool and find the one that's right for them. So that's a great adaptation that they have. They're also, you can notice their bodies, they are very long and they're kind of low to the ground. So they're wider and they're pretty squat. And so that's going to help them to navigate into small spaces. So if you notice how the tide pool is set up, a lot of rocks have little crevices, they have little holes where animals will go to hide. Yeah, so you can see here that it's sort of unpredictable, right? There could be many different shaped holes in one tide pool and then maybe fewer in another, but each tide pool is very unique. It's its own microhabitat. So animals like crabs are going to want to find a place where they can hide, and they can do that by moving around. Yeah, we have a great picture here of another type of tide pool. So this one has a little bit fewer rocks, but still you can notice it is that iconic tide pool habitat because there are these pools of water that are going to get replenished during high tide, and then they're going to be sort of left alone during low tide as the tide recedes. So you can notice here they're found along rocky coastlines, so you can find tide pools anywhere where you have a rocky coastline. And you can actually go tide pooling yourself. This is a really fun thing to do, to get outside and make observations like scientists. There's many tide pools locally in the area that you could go to. It's also a great way to get involved with ocean conservation, because some of the threats that actually are affecting tide pools are some runoff pollution. So this is pollution from cities, from homes, from golf courses. So this is extra nutrients that are running off into the water and affecting these tide pool habitats. So, oh yes, and please go ahead and text your live questions. Again, our number is 562-286-1838. Another threat to tide pools would be trash. So sometimes trash can be dangerous. It can injure animals. It can get in the way of animals feeding. Another threat would be, of course, climate change. So we learned that some of the non-living factors that affect animals living in a tide pool would be sunlight, would be heat, salinity, and the evaporation of these tide pool habitats. And so with climate change, as days get hotter, that's going to make it that much harder for these animals to live in the tide pool because there's going to be more evaporation. So it's going to cause higher salinities because when water evaporates, only the fresh water is evaporating from these saltwater pools. Also, it's going to be more challenging because it'll mean hotter water and it'll mean even more brighter sunlight. It'll mean even stronger sunlight for them, so even hotter conditions. So it's really important to spread the word. Again, go ahead and email us questions at live.lbaop.org if you're watching after the fact. Thank you all for joining us today, and we hope to see you again at Aquarium Online Academy. Bye!